three vital data types in Swift that enables us to build very complex apps, right? We saw enums, enumerations. We saw structs or structures. We saw classes, right? Today, we will wrap up with what we saw so far, right? Highlight the differences, and end out by talking about initialization and what sorts of initializations we have in Swift. Okay? So to start off, we spoke about structs. And to start a struct, you use the struct keyword, right? A struct holds properties, it holds methods, it has initializations. Anybody remember what's the default initialization called in structs? Structs come with an initializer. What's that initializer called? What's that? A what? Structs come, okay, so let's create a struct called fellow. Yes, member-wise, exactly. So as Tiffany said, it's called member-wise initializer. So when I create my struct fellow, and I start out by saying a fellow has an age, for example, it's an integer. A fellow has a cohort. In that case, we'll just say it's a double for now. Make those variables. So we said if we want to go and create an instance, anybody could explain to me what an instance is? Yulia, what's an instance? If I say create an instance, what am I doing? Okay, of that type, right? So I'm creating a variable or an instance of that type. If I was told create an instance of fellow, I would start out by either creating a constant or a variable. In our case here, I'll create a variable called Yulia. Yulia is a fellow. I start out with typing out fellow, open parens. Now, as opposed to classes, here we have what's called a member-wise initializer. Every variable that's not defaulted, it gives us the option to give it a default. Age doesn't have a default, correct? Cohort doesn't have a default. Everybody sees that. So now my struct gives me a member-wise initializer to be able to set my properties. So now I press enter, I give the fellow an age, and I give the fellow a cohort. Right? So here we are making use of structs member-wise initializer. Right? If we were to do the same thing on a class, does a class have a member-wise initializer? Everybody sees that, right? Zara, does a class have a member-wise initializer? Right? So member-wise initializer is that initializer that we get to set our properties on a struct. Cool? So if I was to create a class, call it animal, right? And I say the animal has, bless you, an age, for example, again here. Animal has a breed. Right? At this point, does that code compile? Well, obviously it doesn't compile. The error got thrown up already. Why doesn't it compile? Luba? We need to initialize age and breed. Everybody sees that. Age does not have a value. Do we see that, Seren? Right? Breed does not have a value. Right? 1, correct? Yes? Yeah. Right? Yes, sir. Yeah, you could give them defaults, right? I could say age is 7, and I could say breed, right? I could give them default values. At this point, my code compiles. Everybody with me? So if your properties, all your properties have default values, you do not need to specify an initializer in a class. Everybody with me? Right? But the minute you do not have a default, for example, breed here, you'll get a compiler error. The compiler wants every single property to have a default value in a class. Hannah? Right? Joshua? All right, very good. So here, let's go back to our non-default values. How do we create an initializer for that class animal? Jahid? What's that? Go ahead, come and do it, actually. Sorry. So currently, we do not have an initializer. The compiler threw in an error. We have the option to just set age to a value and read to a value, but that's not what we'll be doing.
So you want to keep it a string, right?
Yeah, keep them default. Yeah. So remove the equal sign. I want you to create an initializer for me. How do we start an initializer?
I thought that was just an open string.
I'm sorry? Init. So you want to press return and type in init, the word init. So init here is the keyword for initializer, and you have an open parens. Open parens. What do we put in init here? What parameters are we passing? I'm sorry? Amini, what's the first parameter will you pass here? Age. So I'll pass age. Colon. What type is age?
Int.
Very good. And followed by a comma.
And breed.
So here, Jahid is creating an initializer for animal. So put in curly. Close curly. And what is the next step? How do we give that age a variable? Or how do we set that age? So the instance, so on that instance, we set that instance age. So we say self.age. Yeah. So here, what do? What do you pass age?
Age is an int.
So age is that value coming in the function, age. So equal age.
Okay. And that would be the same with the breed, right?
Yeah, exactly. Cool. Thank you, sir. So it's very important that we know a class, if it doesn't have default values, we need to go ahead and create this initializer here. The initializer needs to take in all the parameters that hasn't been initialized. Everybody with me? If I have a variable here, right, color, for example, it's a string, and I put in white. At this point, I do not have to pass in color because color has a default value. Everybody with me? Right? Color has a default value. I do not have to initialize color using my initializer. I only use my initializer for properties that does not have a value. Right? Age does not have a value. Breed does not have a value. And I'm inside of a class. Yes? The top one and the bottom one. You mean the struct? So the struct by nature comes with a default initializer, which is called the member-wise initializer. That member-wise initializer takes all the parameters or all the properties that doesn't have a value, and it creates this member-wise initializer for us to use. So we do not have to do extra work there. Does that make sense? Very good. Yes? What if you made the property optional? What value would it have? But what would the value of an optional have? Nil, right? So it has a value. Does that make sense? Right? Everybody, very important. I'm not going to bring it up there for now. But if you have an optional, it has a value, correct? If I say age optional like that, what is the value of age? Nil, right? Nil that's a value. I have a value there. But if I do not have this optional, there's nothing. Nothing is present. You with me?
Yeah.
All right. Very good. Okay, so this is one of the huge differences between a class. We could probably start writing it out. Differences between exactly, because it has a value already. It has a value of nil. Okay, so here are differences between class and structs. We have structs have a member-wise initializer. Classes do not. Classes have to provide an initializer if any of its properties do not have a default value. We all understand default value, right? What it means? A default value is if I have age here and it has some value, right? That's a default value. Everybody with me? So that's what I mean when I say default value. You set it to some value. Cool. Age wasn't int. Awesome. Great. So let's do one thing on classes here. So we have a class, we have a next class, it's called dog. And we said dog could inherit from animal. Right? Dog inherits from animal. In that case, if I create a dog, an instance of a dog, we created a French bulldog. Right? Here we inherited our parents' initializer. Right? So we spoke about inheritance here. So here dog is inheriting animal. Right? The subclass is dog. What's the parent class? Right, so parent class is animal. Right? And as we see in our dog body, there's nothing, right? Everybody with me? There's no properties, there's no methods, there's no initializers. So where do we get that initializer from when we say dog parents? We get it from our parent. Everybody with me? Right? I got it from my parent. So now I could set my own properties, my breed. Right? If I have an info on my parent, we could create an instance method on our parent here. So instance method, call it info. And here just print the breed is age. And if we use color, so the breed is some age old, and color is color here. So here we have an instance method. Instance method could only be used on the instance. So how do we call info? How do I call info? Brendan, how do I call info? What's our instance so far? We've created an instance here of dog. What is it? What's the instance called? French Bulldog, right? So we have a French Bulldog, and the way to access this instance method is on that instance French Bulldog, correct? So I would say French Bulldog.info, correct? So French Bulldog.info here. So far, so good? Any questions here? Instance method is called instance method because it works only on an instance of that type. The type is dog. The instance is French Bulldog, right? The type is dog. The instance is the one we created, French Bulldog, right? So here, instance created an instance of dog called French Bulldog. And now we could use that instance to call our instance method, right? We said methods are functions, but inside of a type, it's called a method. Everybody with me? So here we say French Bulldog, we run our playgrounds. And indeed, we get the French Bulldog, right? We set that there on our initializer, French Bulldog, is 11. We also set 11 in the initializer. So far, so good. So far, so good. Did we have to pass color in our initializer? No, because it has a default. And look, we also got the color here. The French Bulldog is 11 years old, and the color is white. Everybody with me? So we got what the parent had. The parent default for color is white. We could override that color. So this is inheritance here, right? We spoke about inheritance. This is inheritance here. So one of the other differences between, can I go up? Can I go up? So one of the other differences between classes and structs are classes have inheritance and structs do not. Cool? Yeah. Where am I? That might be a good question you're bringing up there. Where am I? No, you could do that with a struct as well. Yeah, because remember, this is a constant. I'm not changing anything by calling info. What do you mean? Did you change the value of something like French Bulldog age? Like this? What are we changing? The color to black? Is that what? Give me an example. There's mutability there, right? The class is mutable if the variables, well, if the properties are variables, right? The struct is immutable if the instance is a constant and the properties even is a variable, it is still immutable, right? But we'll get into that more, okay? Cool. So we spoke about structs. Let's talk about mutating functions because we haven't seen that officially. So if I have my fellow here, struct fellow, everybody has struct fellow. So far, so good? I have a struct fellow. I'll create some, let's create a function called employed. Right? So here I have an instance function called employed. Everybody with me? Everybody with me? I'm in the fellow struct, right? I have two properties. I have one instance method. So far, so good. I have an instance method called employed, which takes in some Boolean, is employed. Right? Everybody with me still? Right? So here I'll create a third property, call it currently employed. and set that to a Boolean type. Right? Already, we need to update our Julia here. Let's update Julia before we continue. Get rid of that error. So here we need our current employed. Just put that up and put false. Okay, so we updated Julia because we have a third property. And our member-wise initializer sees that. It throws up an error because it's like, hey, dude, you need to add this new property to your initializer. Everybody with me? Great, so now we have 3 properties on our fellow. Now, employed here, if I say employed, currently employed, gets is employed, like that, right? I get an error. I'm in a struct. I'm trying to change one of the properties. The compiler is like, hey, you have a copy of something. A struct is passed by value. We all remember, right? We all remember structs are passed by value, right? So by nature, it's immutable. By nature, somebody else cannot change me. Everybody with me? That's a fundamental understanding of why we have to do what we have to do. I have a struct. It's a copy, right? The whole point of having a struct is to say somebody else cannot change my copy. Everybody with me? Right? Mel cannot come around and change my copy of my whiteboard. It's mine. But if for some reason you want to change a property on a struct, you're in a function. Here I want to change a property. So far so good. Do we want to change a property? Is that assigning? That's changing a property, correct? I'm saying currently employed gets this new whatever that is, true or false. It changes my property. Everybody with me? I'm about to change my currently employed property from true to false or false to true. Everybody with me? So that says to struct here, hey, somebody's about to change your property. This is not allowed. The only way it's allowed is to explicitly write the function mutated, right? That is the only way this is allowed. Because by nature, a struct is immutable, meaning you cannot change it. Everybody with me? If you want to change one of its properties inside of a function, this is what we're doing here currently, correct? I'm inside of a function, I want to change a property on the struct. Everybody with me? If you want to change some other property that's not here, it doesn't matter. So if I have like let var, like let test var equal to is employed, I have a local variable, right? The function doesn't care. Everybody with me? But if I want to change one of my properties, how many properties does the struct have? How many properties does the struct have? 3, right? It has an age, a cohort, and currently employed. What's the value for currently employed? It could be what? True or false. So far, so good. So far, so good. So is employed could only be valid. It could be true or false. Do we agree? So if somebody calls employed, they could only pass in true or false. Do we agree with that? Okay. So somebody changes true or false. We are at the end of the cohort. Now I'm employed. Employed gets true. I want to pass it over to, let's take that out here. I want to pass it over. I want to set my currently employed. Because currently, Julia is not employed, correct? We said Julia is false here. Do we agree? So by the end of the program, Julia applies, right? She gets rejections. Then finally, she gets this one offer. Awesome, she's employed. We want to change that. Is that correct? If I want to change this struct property, I'm in a function here. I have to mark the function mutated. Mutated means change it. Everybody with me? Mutate means to change, yes? So here I need to mark my function mutated, like that. Right? And now the code is happy, the compiler is happy. I'm in a struct. I'm explicitly saying, yes, I know what I'm doing. I want to change currently employed. I want to update that status. Yes?
So you're saying that even the function
It's not, exactly. Exactly. So right now, as it stands, my currently employed cannot be changed in a function like that. It cannot, because it's immutable. But most reasons, we want to change currently employed, right, by some outside function, right? So somebody calls employed, they want to change my status from unemployed to employed. Yes, sir. Sorry. I keep seeing a hat here. You see, that's why we need to change you guys. Um,
Sure why you're changing the struct.
it's one subcase, but somebody's changing your property, right? When we go down to Julia here, when we go to Julia, we say Julia dot current employed, right? We're changing it. Somebody's changing my instance, right? I'm about to change this property on Julia. I'm about to say Julia now is employed, like that. I'm changing the properties of the struct. You with me? I'm updating the property. I'm not changing the both to anything. I'm updating it. I'm modifying it from false to true. Right? So let's print it out to get some context here. So make that mutating here. So mutating. And let's print what Julia is, right? So we'll have an if statement if Julia currently employed, print else, if she's not currently employed, we'll print some statement. Right? So here we have currently employed. Everybody with me? Right? What gets printed when I run this playground? What gets printed? Right? Everybody agree? Because currently, what's Julia's currently employed status? Is it true or false? It's false, right? So if it's false, it goes into my lunch is on me today. Everybody with me? So let's run that. Right? Lunch is on me today, right? Because currently employed is false. Everybody with me? Chelsea. The mutating for now, no, if you want to change a property, you have to mark the function mutated. Right? That's it for now. It's going to grow on us, and we'll know as we go through the program. Yes? Yes, it's still an instance method. We haven't changed it. There's only two types of method, instance and class method, or type method. It's still an instance method. So this is still an instance method. Still works only in the instance. So for now, to recap, if you're in a struct, only a struct, if you're in a struct and you want to change one of the properties on a struct, right? You're in a function, you want to change one of the properties on a struct, you have to mark the function mutated. I want to change the properties of this function. I want to change the properties on my struct. That's what you're telling the compiler. Everybody with me, right? In a class, we don't have to do that because the class is reference type. You could do whatever you want as long as you have access to that reference. So that's one of the differences, again, on a struct here. So let's go write our differences. So we have structs. We'll say due to the nature of the immutability of a struct, if you're in a function that modifies one of its properties, that function or method, that method needs to be explicitly marked mutated. In classes, this is not. Right? Because classes are parsed by reference, which makes it mutable by default. Okay? So you in a struct, you change one of its properties in a function, you have to mark it mutated. If you see that code, that's a compiler error. So if you see code like this, be careful there. You see code like that, currently employed, it does exist, right? Does the code compile? First look to see if it's a struct. If it's a struct, you're changing one of the properties here, you do not have mutated, does not compile. Everybody with me? Right? You need to explicitly mark it mutated. Yes, question? Slack the description or? Okay. Are you broken? All right, it's come in. You're welcome. Okay. Good. Let's keep going. So here we have an instance type. We've only seen instance methods so far. Today, let's see what's called a type method, or you might see class method. Well, that's not a class, but you might see type method, class method for classes. But let's see what's called a type method. Actually, let's put it above the instance method. So here we'll put a type method. So remember, when you organize in your code, properties come first, regardless of struct or class. Properties, followed by initializers, if there's any. Bless you. Followed by type methods, followed by instance methods. Everybody with me? Yeah. I'm not in a superclass. I'm not, well, we can even talk about superclass, right? Because we know we're not inherited. Override is for class. Yeah, you cannot override in a struct, right? No, that's fine. Good. Yeah, if you see override in a struct, there's problems there. All right, cool. All right, so initialize, if any, we have our type methods. Here we'll create a type method. Let's create a type method. We will call it function, static. Starts with the keyword static, right? You start off with static. That implies it's a type method. What's a type method? A type method, you call it on the type. With int, we have type methods like min and max. We say int.max. We don't create an instance of int. Let me go back and show us what we're talking about. So here, if I say int print int dot max, for example, right? Run that. Right? We get some value here. That int here, int is the type. We all agree? Int is a type. It's a built-in type. Everybody agree with me? On int, I could call dot max here. Right? That's a type property. I do not have to create an instance of int to get access to max or min or whatever it is. Right? When we say type method or type property, that means you call the method or the property using the data type. I don't create an instance of int. Like I do not say, for example, let some int equal to like whatever, 0 like this. And if I say some int dot max like that, that's not going to work. Because now some int is an instance. Some int now is an instance of an integer. Everybody agree with me? If we option click on some int, what do we see? Option click on some int, what do we get? It's an integer, correct? I can't say int.max. I can't say some int.max. Because this max here only works on the type. The type is what? What's the type? Int, right? So dot max here only works. So example dot max only works on the type. I'll put that in Max is a property. It just gets you the maximum integer possible on this particular computer. Right? So you can go beyond this number. Right? You with me? But that's just a property on integer. So here, there's other properties on integers, right? No. Yeah, it just true or false. Yeah. All right, so here, but that's just illustration purposes to show us what's a type method, type property, versus an instance method or instance property. Right, so here we have in that max is an instance, let's see. So for example, max only works on the type int, right? Not an instance of int. I guess we should stay here and really see what the difference is. So line 30 says, get me the maximum value of an integer on my computer. Everybody with me? That goes beyond any instance. Doesn't matter what instance it is. Integer, the type, get me the maximum allowed value on that type. Everybody with me? So you're querying the type. What is your maximum value? This here is a type property, right? This is known as a type property. As accessing a type property. Right? We agreed we can't create an instance, so here we have an instance of int. Right? Here we have an instance of int, and this is a compiler error, right? Does not compile. Does not compile because an instance of int cannot call type property. Right? So those are the two things here. Type property and instance property, right? Instance property works on an instance. I could say some int okay, so instance of an int here, this is good. This does not compile, so comment that out before we have problems here. And let's show what our fellow looks like with instance properties and instance methods. Okay, so let's go back to our fellow. All fellows belong to some cohort, right? Or all fellows belong to some current year. So here we have our fellow struct. I could create some static or some type property here. Let's go down. So here we have properties. Those are instance properties. Instance properties. And below our instance properties, actually above, we'll have our type properties. Type properties. All right. So type properties begin with a static, the static keyword. So here I'll have a static, call it current year, and current year 2019. So by using the static keyword here, I'm making this property a type property, right? So the static keyword is key here. The static keyword makes that property a type property. I could say fellow.current year. Right? So far, we've seen instance properties. We've used them throughout last week. But today, we're seeing type properties, and we'll also see what a type method is. Right? So in our struct, we have properties here. Those are all properties below here. We have type properties, and we have instance properties. Two types of properties. Right? Either you call that property on the instance. In our case, we could say Julia.age. That's valid. Right? But I cannot say fellow.age. Right, example, I could say Julia, Julia.age, but not fellow.age, right? Fellow is a type. Fellow cannot have age. That's a bit weird, right? But an instance of a fellow needs to have an age. Everybody with me? Right? So that's the differences here. This is an instance property, accessing it from the instance, Julia. This here is not an instance property, age. We can't access it by fellow.age. But we could say on our current year, fellow.current year. Can we say Julia.current year? Right, that would be a compiler error. So here, Julia.current year would be a compiler. My intention is to use a project to make that more, to put it into more context, because we're just throwing out words right now. Static, what's all that mean? How can I use it? Every fellow. Every fellow, the current year would be 2019. Every instance. Doesn't matter, right? Okay, so let's use that. So we've seen type properties, let's use it. So let's go down right below here. Let's say fellow, so we print it out, maybe print it out. So print pursuit fellows current year is, and here we say fellow dot current year, like that. And I run my code. And I get pursuit fellows current year is 2019. Everybody with me, right? So it doesn't matter, I don't have to create, well, I can create an instance, cannot. This works on the type. The type is what? The type is fellow, right? This is not an instance, this is the type. This is a type property, right? Current year is a property. We make it a type property by the keyword static. Everybody with me? Yes, for every type, just the type itself, on the type. It works on the type. Static says it works on the type. Yes, every instance is the same. Like on int, every int, the maximum is that number we saw. Cool? Doesn't matter what it is. But as a maximum, you could go on that particular int. So far, so good? Okay, any questions about type methods? So you'll be, they could be called type methods. Sometimes you see class methods. You even see static methods, right? So we'll see all those. We'll see type methods. You'll see class methods some places. Also for class. But on the class, you could use class. I don't want to use too many keywords, just throw out keywords right now. I want to keep it simple. So for now, just use static on class or struct. Everybody with me? Okay, so type method, class method. You also see static methods being used too. But in the language guide, they do use type methods as the terminology for that. So let's go up here. So type properties, you also see class properties and static properties. Obviously, class only works on class here, but you'll see those. But the basis is type property or type method. Okay, cool. Let's create a type method. How would a type method begin? What's the one keyword we use on a type property to differentiate it? Static, right? So we begin a type method with static keyword. Everybody with me? Static. So here we say static function. We'll call it program info. We'll call it program info. And here we will have a print statement saying this is a 10 extensive How can we call this program info? Do we call it on the instance? Do we call it on the type itself? Right? Stephanie, how would you call program info? On the instance or the type? Like if you were to print, if you were to call this method, how would you call it? Would you create an instance on it and call it on the instance? Like Julia.program info, would that work? Okay, so let's go ahead and test it now. So here, if I say Julia, do I still have Julia somewhere? Okay. So if I go to Julia, where we created the instance of Julia, if I say Julia, like that, Julia.programinfo, well, part of like using Xcode is it gives you hints. Does that thing exist? Already we typing it out, it doesn't show up, right? We could keep typing it out and say, yes, it does exist here. Program info like that, right? And run it. And here, look at what the compiler is saying. Static member program info cannot be used on an instance of the type fellow. Everybody sees that, right? So those little things here, the compiler is giving us the exact message, the error. Go fix that, right? So hey, it even tells you if you want to fix it, how you fix it. By on the type, right? Static member program info cannot be used on instance of fellow. It's a type method. You cannot use it on an instance. Everybody with me, right? So here, the only way we could call program info is by using the type fellow, right? And now we could run our program and get the program info. It's a 10-month intensive program, right? So here we are making use or accessing a type method, right? And the type method is program info. Everybody with me? So far, so good? So we've seen static, you see, I like to use static methods, the name itself. We've seen type methods and we've seen type properties. Everybody? And the word type tells us what it is. It only works on the type, right? So here we have a type method, only works on the type. The type here is fellow. So far, so good? So this is a type method. And we had earlier, we had current year. What did we use current year? Let's just type out current year. I thought we did current year. Yeah, we typed out current year, no? Oh, right here. So we used on line 42 accessing a type property. Right? So let's just copy it and keep it the same place so it's not confusing. So I will cut this. I'll go ahead and cut this. Command X. And I'll go down to where we have our type method so it's not confusing when we're looking at it. So firstly, we saw a type property, which is the type followed by the property. Everybody with me? Right? And then we saw a type method, the type and the method name. Everybody with me? Right? Okay. Any questions so far? And also works on classes. Classes could have type methods, type properties as well. But we'll see that being more used in the project we build today, or we start to build today, right? Because right now there's a lot of moving parts there. Like, how do you use this? What's the point of using that, right? You have a game. You might want the highest scorer on the game. You don't want the highest scorer on an instance of the game. You want the highest scorer on the whole game, on every instance of the game. Everybody with me? Right? So it makes sense to have a type property or type method there returning you that highest score. Everybody with me? Yes, sir. Yes, universal or global. Very good. So as Christian is saying, static, think about it like a global. It is global. It's global to every instance of that particular application running. Yeah, very good. All right, so that's type properties and type methods here. Oh, I think we had a homework question based on that, right? Like static methods or type methods in the classes, maybe. Julia, that was probably your question, right? Does that open up? Is that clearer now? Oh. Okay. All right. Very good. Okay. Let us see. Actually, I'll stop this here unless you have any questions. Any questions? So far, what we've seen some differences between classes and structs. I'm not going to show the initializers right now, right? But that's also a difference. Actually, we could write it down, but I'm not going to show it right now. Classes have the initializers. Structs not. Right? So just to overview what we did, we reviewed what a struct is. We created a fellow struct. The fellow struct has this current year. It's a type property, not an instance property, right? Instance properties do not have static keyword here. If you see static, think type right away. Everybody with me? Right? You see the static keyword, think type. Here, this is a property, so it's a type property. Everybody with me? Right? So moving on, we have 3 instance properties here. We don't have an initializer on our struct. We have, what is this? This is a type method, right? Again, you see the static keyword. It's that global keyword, as Christian was saying. So here we have a static function program info. It's a type method. Only works on the type. The only way I have access to program info is by saying explicitly fellow.programinfo. Everybody with me? You do not create an instance. Like I do not say Julia.programinfo. That's a compiler error, right? We spoke about mutating functions, and we made this function mutating because we changed or we modified one of its properties. Everybody with me? The property was currently employed. We modified it based on true or false coming in from is employed. So that's mutating functions. We showed an example of int here having a type property called max. It just returns you the maximum value of an integer. That was for illustration purposes only, just to show you built-in types have their own type methods and type properties. So far, so good. We went on to create an instance of Julia, right? We used this instance, or we created this instance using the member-wise initializer. The member-wise initializer on a struct gives you access to all properties that haven't gotten default values. We didn't have a default value for age, nor cohort, nor currently employed. Everybody with me? Moving on, we tested our Julia instance to see if she was currently employed, right? At that point, she was not, right? It was false. We went on to test our type property on fellow. So get me the current year on all instances of fellows, right? In that case, we returned us 2019. And we use the type method programming for here to get the information of that particular fellows program. We spoke about inheritance in classes. The structs have inheritance. We agree that structs do not, right? We had to create this initializer on our class because age doesn't have a value, breed doesn't have a value. Everybody with me? Somebody pointed out, if this is optional, it would have nil at that case. And nil is a default value. Everybody with me? Okay, cool. We saw an instance method in review again. This is an instance method. It doesn't have the static keyword, right? So it works only on the instance. An instance of animal. This is going to be work, right? Here we have dog. Dog inherits from animal, right? So dog has all the properties, initializers, and methods of an animal. We went on, we created an instance of a dog, age 11, the breed French Bulldog, And we were able to call the instance method on French Bulldog. Right? So far, so good. Okay, so that is what we did for the review here. So I'll stop now. Any questions? So far, so good? Questions? Yes, very.